Hey guys, we are ready for lesson 14 of unit 4. It's our last lesson of this unit. It's about adding and subtracting money. So we're going to be working with decimal addition and subtraction strategies to add and subtract the money. And we're also going to be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. So let's do a little warm up here. It says, write the decimal, then around the decimals as indicated. So this word right here should be round, not a round. So let's look at the first one. It says, write 7.2894. Okay, write 7.2894. Do this on a slate or a piece of paper and round it to the nearest thousandth. Round it to the nearest thousandth. So when you're looking at this one, we see that it goes many place values past the thousandth. We know that the first one is the tenths, second one is the hundredths, and the third one is the thousandth. So I'm going to put that little green dot underneath the thousandths place. So remember that 4 is going to be the boss. The 4 is going to tell that 9 to either go up or it's going to round down. And so we know 4 is less than 5. So this number should round to 7 and 290 thousandths, 290, because that 9 is going to round up to a 10, which bumps that 8 up to a 9. The next one, write 8.2938, 8.2938, and round it to the nearest thousandth. So again, I'm going to put that dot underneath a thousandths place. And the 8 is going to tell us what to do. And the 8 is going to tell the 3 to round up. We've got 8 and 294 thousandths. Now I want to go back to this first one because I did make an error. That 4 tells the 9 to stay. So we will drop that 4 and it'll just remain the same, 7 and 289. I apologize for that error. As you see, we've got to pay attention to the numbers that are telling us whether to round up or round down. And it's okay if you make that error. You just go back and correct it. Let's go ahead and move on. Like we said, we're working with adding and subtracting. Clear our board here. We're going to solve the following number stories, and we want you to explain your strategies. So if you are in class, you can turn to a partner and explain your strategies to a shoulder partner. If you're at home, try explaining your strategies to a family member, a pet, or to yourself. First one is in blue. It says you had $1.46 in your piggy bank. You found 17 cents between the couch cushions. How much money do you have now? The second one, you bought a vegetable tray for $12.19. You paid with a $20 bill. How much change did you get? Go ahead, pause the video, complete problems 1 and 2. Be prepared to explain your strategies, remember, to a partner, a family member, a pet, or yourself, and then come back. Okay, so some sample strategies for problem 1, which was the addition problem, was $1.46 plus 17 cents. We see that it equals T. So you need to think of a dollar as a whole, a dime as a tenth, and a penny as a hundredth. Then use a grid to solve. You can shade one whole grid, 4 columns and 6 squares in one color for $1.46. Then you can shade one more column and 7 more squares in a second color for 17 cents. Now, one whole grid, 6 full columns, and 3 squares are shaded all, which is 1.63, 1 63 hundredths, or $1.63. Now, again, that is just a strategy. That's a sample strategy. Here is another strategy, adding them like when you add decimals. So we can have $1.46 and 17 cents, which is 1 46 hundredths plus 17 hundredths. If we do it in like partial sums, we see that we can add the 1 plus the 0 is $1. 4 tenths plus 1 tenth is 5 tenths or 50 cents. And then 6 pennies plus 7 pennies or 6 hundredths plus 7 hundredths is 13 hundredths, getting us a total of 1 63 hundredths or $1.63. Finally, U.S. traditional algorithm to solve, you've got it lined up just the same as the partial, except this time you start with the 6 and the 7, which is 13. So you put your 3, carry your 1, and then you do 4 plus 1 plus 1 is 6. 1 plus 0 is 1, getting $1.63 again. Again, doesn't matter which strategy you used, you still should receive $1.63 once you add those two totals together. Moving on to problem number 2, which was $20 minus $12.19. You can use counting up subtraction to count up from the cost of the amount. So you could start at $12.19, count up 1 penny to get to $12.20, then count up 80 more cents. That gives you to $13. Then count up 7 more dollars. That gives you 20. So that tells you 1 penny plus 80 cents plus $7 gives you a total of $7.81 to get from the cost to 20. That means that your change is $7.81. That's the counting up method. You could also think about $20 as $19.01. This is a little bit like trade for subtraction because $20 is renamed before doing any subtraction. So $19 minus $12 equals $7. And then 100 cents minus 19 cents is 81 cents. Again, leaving you with $7.81. And then finally, you can use the U.S. traditional subtraction algorithm, which you see here. You've got the $20 minus $12.19. You see that we've got 3 zeros in a row, so you borrow. We can't borrow from the zero, so we can't borrow from this zero, so we have to borrow from this 2, turning it into a 1, making this a 10. That changes into a 9, makes this a 10. That turns into a 9, makes this a 10. So we've got 10 minus 9 is 1, 9 minus 1 is 8, 9 minus 2 is 7, and 1 minus 1 is 0, leaving us again with $7.81. So in the previous lessons, we used grids to help us solve decimal subtraction problems. So you could also use a grid, and you can look back in the previous lessons to view that. But ask yourself, would shading grids be an efficient strategy for solving this problem? I want you to reflect on that. Why do you think it would be, or why not? And why do the strategies for adding and subtracting decimals also work for adding and subtracting money? Think, what do those two things have in common? Decimals and money. Okay, so we are not actually going to play that game today in this lesson. So just a reminder that money and decimals are the same, because when we're looking at a dollar with cents, we have a decimal. And we know that it takes 100 pennies to make $1. So that connects to the 100th place. If we have anything past the 100th, that tells us that we're probably going to round up in our money, much like when we talked in the past about gas station prices. So a little activity here we can do is page 150. This is nothing to do with money and decimals, but it is a nice review of looking at area. This time it is with fractions. So it's a good practice of multiplying fractions and whole numbers. So you will see that this extra activity is on page 150. We've got several rooms at Westview School. We'll have new tile floors installed next year. Each tile is 1 square yard. For each room, you're going to find the number of tiles we need and the area of the floor. So you see the music room is 7.5 yards by 8 yards. The office is 6 yards by 4 1/6 yards. And the cafeteria is 12 yards by 8.5 yards. And the art room is 9 yards by 6 1/3 yards. Pause your video, try those out, and then come back and check what the answers are. Okay, so you'll see the music room. If we take 7.5 times 8, we actually get 60 tiles, which means the area is 60 square yards. The office is 6 yards by 4 1/6. If we take 6 times 4 1/6, we actually get 25 tiles, and that gives us the area of 25 square yards. And finally, the cafeteria, 12 times 8.5 is 102 tiles, giving us an area of 102 square yards. And the art room, 9 times 6 1/3 is 57 tiles, or an area of 57 square yards. So all those fractions really worked out with these multiplication problems, giving us whole number answers. Remember in lesson 414, the main focus was addition and subtraction of money, connecting decimal addition and subtraction to the addition and subtraction of money because of those decimal points, and cents connecting to the hundredth place. This also connects to multi-digit whole numbers with decimals to the hundredths. That is the last lesson of Unit 4, so be looking for a review coming up in the next few days.